Hi there, Mrs. Thompson here, and today we're going over periodic trends part 2. Part 1 we learned about shielding and nuclear charge. So you'll need to refer back to that as we're going to use that to explain electronegativity and ionization energy. First, ionization energy. It's abbreviated IE. This is the energy that it takes to turn an atom into an ion. And when I say turn it into an ion, I'm talking about removing an electron. So the stronger an atom is, the harder it is to remove that electron from that atom because it's pulling it in closer. That means that more energy is required to turn it into an ion. So it would have a higher ionization energy if it's a stronger atom. Now, in terms of ionization energy, we could talk about several ionization energies. And so we usually just talk about the first one, but what the first ionization energy represents is the energy that it takes to remove just that first electron. The second would be the second electron, and the third would be the third electron. So when we talk about first, that would be this one, and then we would move into the next shell and remove the next electron, and so on. In periodic trends, part 1, you learned that the strongest element on the periodic table after combination of nuclear charge and shielding is fluorine, which is right here in this top right-hand corner. And the weakest element on the periodic table is francium, with lots and lots of shells. Okay. Now, strength will determine ionization energy, the amount of energy you have to put in to steal an electron. So the stronger an atom is, the harder it will be to steal that electron. Okay. So from left to right, the ionization energy increases, the more energy you have to put in. From top to bottom, since they're getting weaker and weaker, the ionization energy decreases. So it takes less energy to steal an electron away from francium than it does from cesium. All right, so let's explain the trends. Why is it that the trend shows that atoms increase in ionization energy across a period? Here we go. It says, in terms of shielding, the shielding is constant, but the nuclear charge increases. So the number of protons are increasing. It is that increase in the number of protons that's increasing the nuclear strength of the atom, so it's better able to hold on to those electrons. Okay, next, why is it that the trend shows that atoms decrease in ionization energy as you go down a group? That is because as you gain more energy levels, you gain more shielding. And so the shielding weakens the nucleus, which makes the electrons easier to steal. So it takes less energy. Okay. In our last question here, we're going to discuss which of these atoms has a higher first ionization energy. The one with a higher first ionization energy will be the stronger one because it'll hold on to that electron better. Okay, so we're looking at nitrogen and bismuth. So we have to use a periodic table to be able to figure out which one has a higher first ionization energy. So nitrogen and bismuth are in the same column, the same family. Nitrogen is closer to the top, bismuth is closer to the bottom. Bismuth has more shells than nitrogen, and so therefore it's weaker than nitrogen. Nitrogen is stronger. The stronger one has the higher first ionization energy, so nitrogen is our answer in this one. Next one, barium and bismuth. Those are in the same row or period. Which one is the stronger of those two? Well, remember that as we go across, the shells stay the same, but the number of protons increase. So since the number of protons increase, the nuclear charge increases, and so it gets stronger and stronger from left to right. So bismuth would be stronger than barium, and therefore would have a higher first ionization energy. Okay. Arsenic and chlorine, those aren't actually in the same period or the same group, but what we can see is that chlorine has less energy levels than arsenic does, and so chlorine is stronger, and therefore it has a higher first ionization energy. In terms of quiz or test questions on trends, you need to be able to both explain the why and make a prediction as to which one has a higher first ionization energy. All right, our next trend is electronegativity. So here's our definition. It's shortened En. It's the ability of an atom within a molecule to attract the electrons. And it's those electrons that are being shared while it's in a bond. The stronger an atom is, the more likely it will attract electrons. Makes sense? It's got that stronger magnet, that stronger pull. So you see this cute atom attracting these electrons in this picture. Remember that in terms of strength, you've got your strongest atoms here and your weakest ones here. Okay, so from left to right, since electronegativity has to do with strength, then electronegativity increases from left to right towards the strong elements. And from top to bottom, it decreases because those are weaker. So just imagine these atoms playing tug of war for the electrons that they're sharing, and the stronger one will be better at pulling those electrons in. All right, so questions I can ask. Why is it that the trend shows that atoms increase in electronegativity across a period? So we'll both discuss shielding and nuclear charge. So across a period, shielding is pretty much constant, but the nuclear charge is increasing from left to right. So it says shielding is constant, nuclear charge increases. An increase in protons allows that atom to attract electrons better. So it has a higher electronegativity. The next question, why is it that the trend shows that atoms decrease in electronegativity down a group? So we're going to talk about shielding and nuclear charge. So shielding plays a bigger role. So let's see, as you go down a group, we gain more shells. More shells weakens the nucleus, which makes it less attractive to electrons. All right, we're going to rank these three atoms in terms of electronegativity from lowest to highest based on their position on the periodic table. Lithium, nitrogen, and carbon. So lithium, nitrogen, and carbon are in the same row. We're going to arrange them so that we are going from weakest to strongest, lowest to highest. All right, so the trend is it goes from left to right, weakest, strongest. So that would just be lithium, then carbon, then nitrogen. Okay, then oxygen, silicon, and phosphorus. Those are in the same general area. In terms of shells, oxygen has the least amount of shells, so it's the strongest between phosphorus and sulfur, or actually phosphorus and silicon. Silicon is furthest to the left, so it has less of a nuclear charge, so it's weaker than phosphorus. So it would look like this: silicon, phosphorus, oxygen. All right, and then the last one here, phosphorus, potassium, and magnesium. Okay. Potassium is one level lower, so it's weaker. Magnesium is in the third energy level. And then so is phosphorus, but phosphorus is further to the right, which means it's stronger than magnesium. So it's going to go potassium, magnesium, and then phosphorus. There are a couple of other trends. One is reactivity. It's how likely an atom will react. Things that are on the most extremes of the periodic table tend to react more. All right, metals with low ionization energy are the most reactive. Nonmetals with high ionization energies are the most reactive. We also have metallic character. That's how likely an atom is to lose an electron. Things with low ionization energies are the most metallic. Things that are metals tend to lose electrons. Metals are losers. Okay, so on this periodic table, the most reactive nonmetals are here. The most reactive metals are here. The most metallic are here. And then over here would be the most non-metallic. And this is just a summary of all the trends that we've discussed. Shielding, atomic radius, ionization energy, electronegativity, nuclear charge, and ionic size. I want you to make sure that you not only know these trends, have them memorized, but you can also explain why they're occurring in terms of shielding and nuclear charge, or a combination of those two.